Hello my dear students, welcome back. So for now it's time to start the second unit. So it is a big gap between first unit and second. Anyway, it is fine. So now for your computer science paper 1, the second unit is about data and signals. As you are seeing on the screen right now, this is the syllabus for the second unit, that is data and signals. It consists of periodic analog signal, digital transmission impairment, data rate limit performance, and digital transmission. In that, digital to digital conversion, analog to digital, and transmission modes. This is your second unit. So without making delay, let's start the concept of data and signals. Okay, so now this chapter is totally depend or totally about data and the signals. Fine, then what is the data? Data is the thing which is to be transmitted. Okay, data is the one which we are going to transmit. How we can transmit? Data can be transmitted with the transmission medium. Okay, anyway, you just understand the concept of data now. Data is the one which is to be transmitted, and in our data communication, data must be transformed to electromagnetic signals, because transmission medium can accept the signals in the form of electromagnetic signals. Fine. Okay, now the data are available in two forms. There are two forms of data. One is analog data and another one is digital data. Okay, data can be analog or digital. The term analog data refers to information that is continuous. Okay, hope you know this. The analog data is the one which is continuous data. Okay, and the digital data refers to information that has discrete states. If I give the example for the digital data, the data which is stored in the computer memory, that is digital data, because the data which is stored in the computer either in the form of 0 or in the form of 1. Okay, okay, that is a digital data. If I give the example for analog data, if you see if the human is speaking right now, I am speaking, my sound waves are coming, this is a continuous data, so this is known as analog data. To make differences between analog and digital data, let me take an example of clock. If you see the analog clock, it has three hands: minute, hour, and second. Okay, these hands will be moving continuously, whereas if you take the digital clock, it will switch from the time directly. Say for example, if the time is 10:20, so it will switch from 10:20 to 21 directly. It will not continuously moving. This kind of data we can call it as a digital data. Okay, the theme is I'm going to tell, that is analog and digital. These are the two forms of data. Data may be in the form of analog and data may be in the form of digital. Okay, then what all we are going to discuss for in this topics right now, you can see we are going to discuss about analog, which are mentioned in the form in the blue color text, that is analog and digital data, analog and digital signals, periodic and non-periodic signal. That is our topic to discuss. Okay, fine. Now then what is analog and digital data? That I've already explained. You can see data can be analog or digital. Analog data are continuous and take continuous values. It will take continuous values, not discrete. If it is discrete, that is obviously digital data. Okay, this is the difference between analog and digital data. Analog data are continuous data, whereas digital data have discrete states and take discrete values. What are the discrete states? States might be high, low, okay, 0, 1, or on and off. These are the discrete states, and digital data have discrete values. Analog data have continuous values. Okay, fine. Now we have to discuss about signals. In the signals also, there are two kind of signals. One is analog signal and another one is digital signals. So why we need signal? That is the first question. Signal is needed because the data can be transmitted through the transmission medium before transmitting the data has to be converted in the form of signals. That might be analog signal or that may be digital signal, but there are two forms in a signal. One is analog and another one is digital signal. Okay, so now signals can be analog or digital, the first point you can see. The second point says that analog signal can have an infinite number of values in a range. I will show you how that infinite number of values in a range. Values in a range means you can represent analog signal with a sine wave. You are already aware of the sine waves, right? So sine wave, how you can draw? You are drawing with the connecting points infinitely or continuous points. If you connect and if you draw the sine wave, that is an infinite number of values. So how you can draw digital signal? That is with a square wave. Square wave means there are vertical lines which can show the signal value, that is high low, okay, and the horizontal line to show the time. So that is what digital signals. Okay, so that digital signals can have only a limited number of values. Fine. Okay, now you can see these are the two signals which you are seeing right now. First one is about analog signal. See now, from here if I started to draw from here to here, if I draw like this, so this is a continuous line, right? So how many number of points I have connected if you draw this with a dotted lines? So that is infinite number of values in a range of this analog signal, whereas digital signal is having horizontal and vertical lines, so that these horizontal lines represents time axis and these vertical lines represents value, but the values are discrete, not continuous. This is what digital signal. Okay, hope this is clear to you what is analog and what is digital signal. Okay, data are two types, analog and digital, and signals are also in two types. One is analog signal and another one is digital signal. In the data communication, we can use whether analog signal or digital signal, both are allowed to use. Okay, fine. Now this is our main topic to discuss, that is periodic analog signals. There are two types of a signal that you know, analog and digital signals are there, but with these two types of a signal can use of one of two ways. There are two ways to use these signals. One is periodic signal and another one is non-periodic signal. Remember this point, I am not writing here, just I am telling, you can note it down. Signal may be periodic signal and non-periodic signal. Okay, okay, first we can see periodic analog signal. Now in a data communication we commonly use periodic analog signals and non-periodic digital signals. Remember this point, this is important. In data communication we use periodic analog signal, non-periodic digital signal. Then what is periodic signal or what is periodic analog signal? First you understand periodic signal first. Periodic signal in the sense that signal is having a particular cycle, okay, or particular pattern within a given time period. Okay, some predefined period, that signal how many times it is going to complete its cycle, that kind of signal we call it as a periodic signal. Non-periodic signals means it will not retain any cycle. Okay, it will not retain any cycle for a particular period, that is non-periodic signal. Okay, there are two types, periodic and non-periodic, but in data communication the commonly used signals are periodic analog signals and non-periodic digital signals. Why? Because periodic analog signals need less bandwidth. Periodic analog signals need less bandwidth, that is the reason we use periodic analog signals. And why we use non-periodic digital signal? Because non-periodic digital signals can represent variation in a data, that we will discuss in the later chapters, what is variation in a data and what is less bandwidth and all. Fine, now you just understand that we are using in the data communication that periodic analog signals and non-periodic digital signals. Okay, so periodic analog signals can be classified as simple or a composite. There are, we can classify this periodic analog signal as simple or a composite. A simple periodic analog signal is a sine wave. Okay, and it cannot be decomposed into simpler signals. Means if it is a simple periodic analog signal, that cannot be decomposed again. So if it is a composite signal or composite periodic analog signal, that is composed of multiple sine waves. Getting my point? Multiple sine waves, it means that you can easily decompose that composite periodic analog signal. Okay, so now what we are here to discuss right here. Okay, now we have to understand about sine wave and wavelength, time and frequency domain, composite signal and bandwidth. Hope this you have already know about what is sine wave, wavelength, time and frequency domain, composite signals and bandwidth. Fine. Anyway, we will discuss bit about those things. So sine wave can be represented like this. So vertical lines is the value of the sine wave, and the horizontal line represents a time axis. Fine. So this is a simple sine wave as you are seeing right now. If the number of cycles or number of oscillations are more, then the frequency is high. Okay, that you know, right? And the sine wave is continuous and it is a smooth wave, you can represent here, and it has three parameters, that is peak amplitude, okay, frequency and the phase, that you know. The sine wave or the simple sine wave having three parameters. One is peak amplitude, frequency and the phase. Okay, so whatever you are seeing now, this is the periodic signal, periodic sine wave signal also you can call. Okay, or periodic analog signal. So now you are seeing the sine wave which can represent periodic analog signal. Fine. So now it has three characteristics as I told: peak amplitude, frequency and the phase. Now you can see the peak amplitude is the one where the highest value of the wave represents the peak value, that you are seeing on the diagram right now, which I am showing. This is the point where the highest where signal reaches its highest value, that is a peak amplitude you can call. Correct. And for this signal, the first signal you are seeing, the value, peak amplitude value may be changed, and the peak amplitude of the second wave might be changed, and they, though both the signals having the same time, frequency may be same, there may be changes in the peak amplitude between the signal A and the signal B. Correct. This is about peak amplitude. Fine. The frequency and the period are inverse of each other. This is the important point, that you know. Frequency can be calculated with the 1 by t. If you make inverse of this, you will get the time period, that is t means time period, not just time, it is a time period, or you can call period. Frequency is equals to 1 divided by time, and the time period is equals to t equals to 1 divided by frequency. You will get the time. Fine. So now you can see here two signals with the same amplitude. In the first diagram which you have seen, two signals with the same phase and frequency but different amplitude. See, the frequency is same, okay, for the both waves. Correct. And phase also, zero phase if you call, it is started from the same. Here also it is started from the same end. So these two signals having same phase, okay, and same frequency, number of oscillations are same, right, but different in amplitudes. The height of the first wave is differ than this, right, and the second type of wave you can see two signals with the same amplitude and a phase. Amplitude is same, phase is also same, but different in frequency. Correct. Okay, you know the periods and the frequency. Period is nothing but it is a time, okay, and the frequency is the number of periods in 1 second. Fine. So now in these two signals, the period, okay, and frequency means the signal with the same amplitude and phase but different in frequency. You can call frequency and period in the same context, that I have told it is the inverse of each other, right? It is the same characteristics but in a different way, period and the frequency. So now the amplitude and the phase are same, but those are different in the frequencies. You can see number of periods, how many periods are there in this, 1 by 6 you can call, but here 1 by 12 per second, that is a period. So this is the representation of the sine wave in a periodic analog signal. If you calculate the period for this, how many periods are there within a 1 second, that is 1 by 12 you will get, means 12 periods in 1 second. Okay, for that we can call frequencies of 12 hertz, because 12 periods in 1 second, frequency is 12 hertz obviously. The second one is, how many periods are there in this, 6 periods in 1 second, so frequency is 6 hertz. So this is how we can show the periodic analog signals. Okay, now we can see units of period and frequency. Seconds, okay, 1 second, you can if it is a time period in case of seconds, then frequency is in form of hertz, okay, equivalent to 1 hertz. If it is in millisecond, that is 10 to the power of minus 3 seconds, that we have to write the frequency as kilohertz if you are using 10 to the power minus 3 second. Okay, so that is 10 to the power hertz, 10 to the power of 3 hertz, that is same as kilohertz. 1 kilohertz is equals to 10 raised to 3 hertz, that you know. Microseconds, if you are using 10 to the power of minus 6 seconds in time format, the frequency we can write in the form of megahertz. Okay, megahertz, that is equivalent to 10 raised to 6 hertz, that you know, conversion that you obviously you know. Anyway, nanoseconds, if it time in the form of nanosecond, that is 10 to the power of minus 9, so frequency can be called as gigahertz, 10 to the power of 9 hertz. Okay, so picoseconds, if it is, then 10 to the power minus 12 seconds, so we can call it frequency as terahertz. Terahertz can be written in the form of 10 to the power of 12 hertz, that you know. This is the unit of period and frequency. So one example is given, that is already solved. So you write and you try to solve more example like this. The power we use at home has a frequency of 60 hertz. Okay, the book is written as a American author, so here we are having some different frequency in Indian system. Anyway, so let's take example. The power we use at home has frequency of 60 hertz. The period of this sine wave can be determined as, that you know, time period and frequency value. They are asking about time period. Obviously time period is equals to 1 by frequency. Frequency is already given, that is 60 hertz. So if you write 1 by 60, that is 0.0166 seconds. Okay, if you want to write in the milliseconds, that you have already seen the units, millisecond is given right here. So if you calculate, you will get 0.0166 into 10 to the power 3 millisecond, that equals to 16.6 milliseconds. You note this down. Okay, fine. The next example, you see the period of a signal is 100 milliseconds. Here period is given. Okay, and they have asked about frequency in kilohertz. So you have to note this down, unit, okay, table for units of period and frequency. Easily you can convert. That is very simple examples they are given. Solution is there. First we change 100 milliseconds to seconds. Okay, and then we calculate the frequency from the period. So first what we have to do, that is obviously right. First you need to change that given period, which is given in the form of milliseconds. So you need to convert into seconds. So if you convert it, 1 hertz equal to 10 to the power of minus 3 kilohertz. Now the answer you are seeing, 100 milliseconds is converted, that is equals to 100 into 10 to the power of minus 3 seconds. Okay, fine. Now frequency equal to 1 by t. If you substitute the values, you will get 10 to the power of minus 2 kilohertz. Okay, some examples you have seen. Now we'll discuss a little bit about the frequency. Frequency is the rate of change with respect to time. Frequency is the rate of change with respect to time. Change in a short span of time means high frequency, means number of time periods are more, frequency is high. Okay, means changes are more, frequency is high. If there are less changes, that is frequency is low. Okay, change over a long span of time means low frequency, that is obviously. Okay, if there is no change means there is no frequency. If there is no change means frequency is zero. Okay, if there is huge change, it means frequency is infinite. That's all. Okay, now if a signal does not change at all, its frequency is zero. That only I have told, right? So if the signal changes instantaneously, its frequency is infinite. Okay, fine. Now we have to know about phase. Phase describes the position of the waveform relative to time zero. Means from the beginning, at a time zero, what is the place or what is the position of the waveform that represents phase. Okay, phase describes the position of the waveform relative to time zero. Okay, here you are seeing now three sine waves are there. Okay, three sine waves with the same amplitude and same frequency but differ in a phase. See, same frequency, same amplitude, height is same, frequency, number of time period is same, but they are differ in phase. You can see the phase can be represented in the form of degrees or radians. Okay, degrees or radians, you can use any of the form. Now the diagram is showing with the degrees. Okay, first known as, it is started from the zero relative time, so it has 0 degree. Okay, zero phase, 0 degree. You have seen that in the physics, that phase shift oscillator and all. Anyway, so if it is started from this, like this, the second wave you can see B. Okay, it is shifted right here, it is shifted over the zero axis, right? That is 1/4 time, that is 90 degree. If it is shifted 90 degree, that is 1/4 time, we can call 1/4 time. Okay, so if it is shifted 180 degree, that is 1/2 time, that is 1/2 time. So this is about phase. Okay, with 0 degree, with 90 degree, with 180 degree. If it shifts for 360 degree, what happens? The complete wave is shifted right this. Okay, if it is shifted 360 degree. Okay, now we are saying only 0, 90 and 180. One example is given here. A sine wave is offset 1/6 cycle with respect to time 0. They have given how many cycles with respect to 0 time, what is its phase in degrees and radians. Okay, I have already told phase can be measured in two ways, in form of degrees or radians. We know that one complete cycle means what? 360 degree. Therefore they have given cycle of 1/6 cycle, so 1/6 into 1 cycle means 360. If you multiply 1/6 into 360, what you will get? 60 degree. Okay, 6 6 the 36, that is 60. You will get 60 in the form of degrees. Okay, 60 degree you can convert into radian, that is 60 into 2 pi divided by 360. If you do, you will get the value in the form of radians. Okay, that is equals to pi by 3 radians, that is 1.046. This is all about phase and the example with the phase. One more. Okay, now we have to see a bit about wavelength and the period. Wavelength is now you know the length. Okay, horizontal length between two peak values, or two lower end or two upper end, if you calculate, that is become wavelength. Okay, here you can see transmission medium at a time t, the wavelength. Okay, given transmission medium, the second one at a time t plus t, means on what direction the waves are moving, the direction is given. So don't worry about this. Here this is just a simple signal for the wavelength. Okay. Okay, this is all about today's class. In the next class we have to discuss about time domain and frequency domain. So it is more time if I wanted to explain. We will discuss these things in the next class. Okay, fine. So you just see complete video and note down if you want. Fine, thank you.